First part is the introduction. That will be the basics of 3D printing. Then the orthotics, what are about orthotics, and then main part is that integration of 3D printing in orthotics. And what is the 3D process? This is the basics. And then what can be the future trends for 3D printing and orthotics? So if we go for 3D printing definition, and if you search it, it is they say that it's an action or process of making a physical object from a 3D, three-dimensional digital model, typically by laying down many thin layers of a material in succession. So it means, simple language, I would say that this is the three-dimensional printing. The 3D printing is a additive manufacturing process. The manufacturing process where addition has been done, in which a physical object is created from a digital design. This is important. Digital design by printing thin layers of materials and then fusing them together. So there are three things. One is the additive manufacturing process. This is a general name. If you can see that there is in the market or in website, you can say that additive manufacturing. They don't use the process. They call 3D printing as additive manufacturing. Second is a digital design. Third is the process that is printing from layers of materials and fusing them together. So this is the third step. So first we will go for the what are the different types of 3D printing process. These are the three main types of 3D printing. One is stereolithography, one is fuse deposition modeling, and the third is the selective laser sintering. So first we will go for these three types, and then we will see that what are these techniques, and then we switch to the orthotic side, that which type is good or bad, or how we can process, how we can use these techniques in orthotics. So first of all, stereolithography is a technique where we use the liquid resin, and on that resin the ultraviolet rays is curing the liquid layer by layer. That layer traces the pattern for each, the laser traces the pattern of each layer on the liquid resin, and that laser solidify to create a final object. Commonly, the material that is used are the liquid photopolymer resins that are used, and these are often used with the for the highly detailed, or that the parts that we use for the smooth surface. It's mainly used as jewelry or the dental or the product design. This is the first one, and the second one is the fuse deposition modeling. It, instead of the liquid in this technique, we use the thermoplastic filament, and this is the mostly viewed because now this is FDM technique is available not only in bigger size but in the smaller, very handy kind of 3D printers. So it's very common, easily available, from cheap machines to the very highly efficient machines. The common materials used are ABS and PLA and others we will discuss later. Uh, these are mainly used to make the rapid prototyping, manufacturing of functional parts, and creating concept models. But now this is also used to make orthotics. It's easy to make orthotics with this technique. So we have come to the third technique, that is called SLS, selective laser sintering. Technique, we have seen the liquid, the filaments. Now this in this technique we use the powdered materials for the fusion, which with which we can go for layer by layer technique to create a 3D object. The material which is in powder form can be nylon, polystyrene, and other powdered material which is compatible with the laser sintering. And this is really good technique, and the product is very strong. The functional parts and the commonly used areas are the aerospace, automotive, and medical industries. In orthotics, I have seen very good production for the cranial orthosis and the AFOs. Okay, this is the end of these three techniques introduction. So now comes the question that what is the best option out of these three options, these technologies or techniques that we have just viewed. Um, Look, there are certain strengths and weaknesses with each and every technique. Okay, so we have to decide according to the material properties, resolution requirements, production volume, that and moreover that what type of outcome we are looking for, that object that we need to make for the patient, for the orthotics. So the choice of technology depend upon the specific need of the application. This is really important to understand. Now comes where we can use the 3D printing in orthotics. Now we have seen 3D printed orthotics in cranial helmets, AFOs. There are so good designs available now, and spinal orthotics as well. So the braces are now made with 3D printing, and I have seen good results out of those who has been made with a 3D printer. So if we generally say why 3D printing in orthotics, number one comes to the technology that everyone is coming to the digital model. It's easy to take the measurements. It's easy to take the digital file and edit that. So and customization options with the 3D printing is good. So this is the number one choice where we cannot go for the traditional kind of measurements or manufacturing. We can adopt the 3D printing. It's more easy for patients, more easy for us to make orthosis. Some just like that, if patient is bedridden or patient is inpatient, we cannot do the casting. He needs some kind of splint. So with the just 3D printing, process, we can have a good splint for that patient without bothering him, without doing anything else. Rapid prototyping, that if we have an idea to make something, so we can make different prototypes with 3D printing. This is really good for the research, for the practice. Just like you have a design, you make a prototype, and then it's very finished, it's very cosmetically very good, functionally good. You can see the material, how the material is good, how good is the design, how good is the application, how good is the use. Everything you can go for that. Uh, these materials are commonly lightweight and durable, so you can play with that. Okay, if you need some kind of strength, you need some kind of flexibility. So it's all on you. You don't have a limitation regarding the materials and the cost effective. But people say it's a general idea that the 3D printing the product is cost effective, but there is a different call it parameters, I would say, to get into that cost effective. If you are going for something that is because it's a now market, marketing kind of thing. You need something urgent, the cost will be high. If you are not making anything in a bulk, the cost will be high. If you are doing a production in a bulk, definitely cost will be much lower than the other. So there are a lot of other factors, but still, in some points we can say it's a cost effective as compared to the traditional. Cost effective because it takes less time, less manpower, less resources to make our sources. That's why I think it can be cost effective. Now, if this is the this was the our side, but if you go for the patient response, patient are happy with the customization sometimes because we have different options. We can ask them. We have a lot of um, flavors in our plate to present to the patients. They will be definitely happy. Faster turnaround time, definitely 100%. If you have a good command and you can make an orthosis in according to it depends upon the machine and the technique and your number of the patient, but still you can make a faster turnaround time as compared to the traditional one. Um, Improve comfort, yes, you can say, because there are much higher chances that you can make a precisely good design for the patient, better setting, you have a good options. Cost effective, still patient is happy with the quality. Sometime if it is very complicated, the cost will be high, or the technique you are using, the material is costly available, because this material, for the material we have to keep that material in a specific temperature, specific environment, and it's not easy to get that material sometime. So if you are getting one kind of material specifically for one patient and you are getting from far, the chances are different that the cost you have to keep that material in a standard kind of temperature, and that temperature maybe it is not maintained during the transportation. So the cost will be high if you can get it, if you want to get it urgently as compared to the regular this the process. Easy adjustment, sometimes it's easy but not all the times. Limitations, definitely there are so many limitations are there because this area is not fully explored for us. So there are still good and bad, and what you call that, still margin of errors, and people still go for the traditional way where we need the high levels of activities with the orthosis. So this picture is very simply describing the process of 3D printing. So first of all, what we need to generate a 3D print is the measurements, right? So for the measurements, we have to go for the digital image or digital data that we need to process. This is the first step. So to acquire this, we need digital scanner. So the scanners we use are known as 3D scanners. There are so many different designs. I remember 5 years ago when, not 5 years ago, in fact, quite 7 years ago, I think. I have seen one 3D printer in Arab Health, and 5 years ago, or 4 years ago, I got one this 3D scanner that is attached to the iPad. This one. So this is a really simple design, simple option. This scanner is attached with the iPad. You can use a application in the iPad, and this can easily scan the body. But the thing is, the difference is from here with this kind of scanner to the other scanners is the accuracy, the margin of accuracy is different. This is very costly, very effective 3D scanner, commonly used. And this now the companies who are dealing with 3D printing or 3D orthotics, they have their own applications. So you just need to take the measurements with those applications through your mobile. The iPhone and iPads are really good with this LDR technology, so they can just take the scan and you can communicate to the company, and company can make it at the place and send it to you. This is centralized fabrication. If you don't have the system or the machine 3D printer with you, so you can just take a scan and send to them. Now, the patient data acquisition is with 3D scanning. You can see that you can do this with the scanners and the photographs and all the things. There are different types of techniques. You can take the scan of the patients according to the need. Now, that scan is now we transfer to the software in the system. Different companies have different softwares. There are so many. Those software have the option to modify that scan. It's just like that you have taken the measurements with the POP bandage, or and now you are filled with the POP, and now you have the model, and you are now modeling the patient, modeling the model. So negative, so positive model. So it's just kind of that. So where you want to add, where you want to remove, what kind of design you want. So you can do this digital design and modification. This is really interesting part, and there's so many options now digitally that you can play with the software to generate a kind of design that you can see how it will work, how where the thickness you can modify, where which how much thickness you need, which kind of curve you want at what point, anything you name it. There are so good softwares available now. I hope in the next session I will try uh, to bring someone who is very expert. He's busy now. Otherwise, I'll bring him, and I'll try my level best to to arrange a live session there where you can see how you can take the measurements, how do digitally you can um, uh, modify the scan. Inshallah, next time I'll bring that one. So once you can see now, there are this is this is the screenshots. In fact, when you see a negative model, this is design, and then you design your brace over it. There are so many softwares now who give you an option that 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 give you option that which kind of A4 you want, which kind of splint you want, or which kind of any brace you want, and they give you the baseline, and that from that baseline you can just modify that area, or according to your customize that area. It's really handy, it's really good. Sometimes you just go for that. Okay, we want double layer. First layer we want the flexible, second we want the second part, we need the hard one. So you can do all this in the software. You can these are basically, this is the part where this is the modeling part. Okay, you make a model, you design that AF4 digitally, and now you export it as a STL file. So the first part, digitally part, is done from your side. Now it's a manufacturing. So 3D printer, that STL file goes to the printer, and that printer that has the material, that has the soft the the integration or syncing with the software, and decide that how they decide everything. It will be done with this printer. um, so the process is completed in different durations. Now it's a big question that how much time it will take. It depends upon the size, thickness, material, and design of the orthosis. Just like for a spinal brace, it takes hours. For AFO, it takes maybe 2 to 3, 5 hours, 6 hours, 4 hours. It depends upon how good is your printer, how fast is your printer, how less complicated is your design, which material you are using, what are the thickness, what is the size, whatever. It depends upon the each and every case. So normally now the printers which are available now, they can give a time frame that how much time it will take. The disadvantage is definitely there, because if there is some error in between the printing, maybe you have to start from the zero again. Zero means start from the process of printing again from the same file. So this is a tricky part of this. Now comes to the materials. Um, how many materials and what kind of materials we can use. So this is the list. There are so many, and but if you see, this list has been prepared according to the this type of material. Is it flexible? Is it rigid or semi-flexible, or the semi-rigid? And there are so many kinds. Just like thermoplastic polyurethane. Number one, if you can see the flexible one. The polyurethane, basically, they have many properties. Um, but they are good into that. They are flexible. Polypropylene, these are semi-rigid, and then there are polyethylene terephthalate glycol. This is very difficult to pronounce that. PTEG, PLA polylactic acid. Then the carbon one. These are more rigid, more strong. Then it comes to the, because this, if you see that there is FFF printing. So we have spoken about F DM printing, but what is FF printing? Because but you have heard also this name. Generally, FF printing is the former name. It was used to be called before fused filament fabrication. Then it comes to 2005. There was a guy company who started using the name of FDM, that is fused deposition modeling. So it's the same thing, but the different names, almost the same. SLA or DLP printing. They use this is stereolithography. ST45 is the urethane, that is urethane photopolymer, because this is a resin based. It's a resin photopolymer resin. And then we come to the, if you see that there is in the resin there is no flexible option, so there is only the hard and semi-rigid or rigid option. Then comes to the SLS or stereolithography, or this MJ F printing. So this is, you can see the powder printing. So there are TPU, the same thermoplastic polyurethane, flexible, available in the powder form. Then polypropylene, and then PA11 and PA12 polyethylene. So these are polyacetylene. Sorry, these are the general idea about these materials are available in the market. For orthotics, there are so many others. Um, how we choose these materials, there are so many options based to select these materials. These can be based on the colors, durability, flexibility, surface finish, printing accuracy, impact resistant, water resistance, and the density, and so many more. So, but according to all these needs or all these qualities of the materials, they are bound with these kind of techniques. Just like filament, they have polypropylene, PLA, PETG, TPU, and then in SLS we can use. So there are common materials we can use in all three techniques, and there are some materials we can use only in one technique. So you have to consult that company, manufacturing company. Before that, before some time, these materials were used available for industries, but now it's used for orthotics as well. Um, it's a good sign that the companies are offering that these materials are now good for orthotics. You can use it, you can try it. They are now available in the market. And these are the advantages. We have already covered it, but still, these are the lightweight, comfort is better, customization is possible, patient compliance is good, acceptance by the patients is good. The demands for the 3D printing, because they search on Google, they find things, they come to us and ask, okay, do you have this? Despite that is good for them or not, but they are asking, there is demand in the market, and then I'm on it that it is truly justified that why they are asking, because everything is going to that direction. Better hygiene, that is a question. So, what is the future? Artificial intelligence and the 3D printing is now coming together. I have attended recently a small workshop. I am not a workshop, you can say it's a kind of a session regarding the use of artificial intelligence and 3D printing for spinal corsets, spinal orthotics. It was very interesting. So the state of the art modern with the patient trunk 3D scans can be done for the spinal orthotics, and this AI helps to find out the design or the correction, the baseline that you can go for each and every individual. But still, I believe that artificial intelligence is not so at the level that you can go for certain things. But for the baseline, yes, it can be helpful. But still, if we use artificial intelligence, it's based on data. So data for a specific kind of community, for a specific kind of area is different from the other. So because artificial intelligence use the general data, so generally something for the medical things, for just these kind of decision making is, it's still debatable.